Okay. Looks like we are up and running. Give it a second to sync. Alright, everything looks good. So, welcome to the 4th edition of Repairs at the Bench. I don't really know what to call this yet. We'll figure it out as we go. But tonight we're going to be working on a RT-10, Klipsch RT-10. This amp was sent to me in pieces. The owner sent me the power supply first. Then I reached out to him and told him I prefer to have the whole unit so we can do the whole thing and do a fully functional test on it. So we're going to do this one start to finish, and we'll see what we come up with. I'm skipping the intro for now. I received some feedback from a few people that have subscribed, and they said the intro is not needed. So you're just going to see me, and we're going to get right into this. So here's where we're at. I started taking this amp apart, and as I was taking the little brackets off that secure the MOSFETs to the heatsink, I noticed that this one has some burning on it. You can kind of, the light will cooperate, you can kind of see that there. There we go. It's nice and crispy and charred there, so if we zoom down in and look, and we'll check that out in a minute, one of the MOSFETs is completely blown. So let's get this power supply out, and we'll give it a once over and see what's going on with it. Now I know that the owner of this did do a little bit of work on it, which is fine. It doesn't look like there's any damage. I guess we'll get into that as we progress through. Hopefully there won't be any through-hole damage though, because that's always a pain. I did do some upgrades to the bench. So when we do our test today, we should be able to fire it into the little oscilloscope that I got, so everybody can see what the waveform will look like. I also did some changes on my, well, let's see if I can pan the camera over and show everybody what I'm working with here. If I can find the controls, there we go. Let's see if we can just twist the camera to look up the side of my wall. So here's what we're looking at. So I have my dummy load here, which is a 4 ohm 300 watt load. That's what I'm testing most of my amplifiers in. It allows it to be silent, so I don't annoy my wife too bad. And I changed my power supply configuration. So on the top, I have a current limited supply, and that's operated by the top switch. And on the bottom, I have a full power supply. And the way I used to do it is I would have to take the bulb out, put a fuse in, and re-switch it. Now, I can leave the current limited supply on, and I can go to full power just by flipping this switch down here. So it makes things a little easier, and I don't have to mess around with changing a fuse in or out. And I have my 100 watt light bulb. This limits the power to roughly around 1 amp going in, so keeps things from blowing up if there's still a problem. Usually, sometimes not always. Usually on some of the Sunfire amps, if I miss something, like the MOSFETs on them are fairly expensive, so it's nice if I can do a little test with current limited supply and not continue to fry things. Sometimes it's necessary to fry things and it actually helps, but not always. Alright, let's see if we can get the camera dialed back in. Good enough. Alright, so let's zoom in on this MOSFET so we can see what it looks like since it's toasted. I still need to get a remote for this camera. It'll make it a lot easier than having to click on everything. Alright, fully zoomed in. But what we can see is, you can kind of see it, it's actually cracked there on the top. It's cracked and you can actually see inside of it right there. So he's going to have to be replaced. And if you look down inside here, I can get the light to cooperate. We have two burn resistors. These are the gate drive resistors for these two MOSFETs. And I'm sure we have some other goodies in there we'll find, as we continue. The owner did change the caps out. I'm going to actually change those caps out again. I mean, these are fine. These are the GN series. I like the GU series just because they're a little bit bigger. Same exact caps, just different form factor. So the can's just a little bit bigger on these. I think they have the same temperature rating. Yeah, same temperature rating, same voltage, same capacitance. This guy's just a little bit bigger, and that makes it nicer when I'm trying to silicone these together in the between. I don't have to put a massive blob in there and get it all over. I think the caps are closer together. So we'll put these in there, and I'll use these smaller ones on a different amp that they actually fit into a little better. I'm also going to probably change out all these. They're VZs, which is a decent cap, but I like the PS series better. So all of these little guys we're going to pop back out, and I'll put the UPS in there. We're also probably going to change the film caps out and finish cleaning up the gunk and the glue in here. So I think to start off, we're going to start pulling the caps out and see where we end up. Let's take a look at the bottom of the board. Oh, I can see we have a problem here. This through hole is gone. It was bound to happen eventually. That's going to drive me nuts. So all the leads where these caps were put in are bent over. Don't bend your cap leads when you replace the cap. Just don't do it, because when it comes to the next tech, they're going to hate you for it. Well, other than one through hole being bad, I think we got a burnt trace too. Got a burnt trace right here, and that goes to the bash control board. All right, well, this one's going to be fun. Maybe we're only going to get to one tonight. First step is we're going to take everything out. My solder sucker's due for a cleaning too, so that might have to happen as well. Been busy lately. I haven't had a whole lot of time. I apologize. Like, I've been wanting to make some videos, but the house stuff and everything else comes first. And I was working on the house today. I put in probably 500 square foot of tile today, so I am a little exhausted, but we will make it through. Alright, solder sucker's heating up. I'm going to start with the large caps. I can tell we're going to have to do some cleaning, so we'll get the dental picks out, get the Euro tool out. Alright. Yeah, these boards, for whatever reason, whenever something goes wrong, these little traces on here evaporate, and I'm going to guess that there's probably something wrong with the dashboard too. Not always, but typically when something's sucking down that much current, usually there's an issue. These two transistors right here are probably going to need to be replaced. We're going to replace both MOSFETs just because, and we'll have to see what's going on down here. Hopefully none of these through holes are bad, but we'll get to see a proper through hole repair. And I mean, this would probably work, but there's nothing holding that in place. The pad is just completely gone, so we will give it a new pad. I believe, yeah, this one makes connection on the top, so it's kind of even more important to make sure that you have a really good contact, so we will make sure that this guy is happy. I'm curious to see what the top side looks like, so we'll do him first. I did not clean off any of the FET, so that silicone thermal paste is going to get all over. Everybody knows how much I love that stuff. And yeah, we're already in trouble because the inner ring of the through hole came out with the cap. Top side surprisingly looks pretty good. So yeah, we'll get a new through hole in there, and we'll be back in business. Not a big deal. Running low on alcohol. Everybody that's panic buying for coronavirus is buying up all the alcohol, and I can't clean boards anymore. Save me some alcohol so I can clean your PCB boards. The top side doesn't look too bad. The glue was cleaned off for the most part. There's still some on the top by some of these leads, and this has to all come off, so you can't leave any of it in there. All of this right there has to come out, and you can see it's turning brown on the leg of that inrush limiter, so that eventually will turn into a short. It'll short to this resistor right there, so that's got to go. No good. Alright, let's take the other two big caps out. The main filter caps. That one tore out the through hole as well, so we have two through holes to repair. Actually, we can get away with, well, we'll do that one anyways. Typically on these boards you get one good rework out of them, and then you're kind of out of luck. And that one also tore part of the through hole out. Yeah, once you get to the second reworking on them, everything just kind of decides to die. Not the highest quality made boards, unfortunately, but not much you can do about it either. This pad looks like it's lifting. It is. Alright, main caps are out. I think I gotta zoom out a little bit, and we need a little light because we have a weird shadow. Let's try that. That's a little bit better. I still haven't figured out all the lighting. I have a nice bright bar light so I can see pretty good, but what the camera sees is definitely not what I'm seeing. I'll try my best to keep that illuminated. We'll zoom out a little bit. That should help. Okay, so we have the main caps out. Now we gotta take the little caps off. And I'm gonna do these one at a time, because I have not remembered where all these go by heart yet. And I don't want to dig out my cap list. These ones don't look too bad. Actually, I need to change my tip. Control board looks okay. Nothing seems burnt. That doesn't mean it's good, but it looks alright. Typically, these two diodes go, and these resistors, these three resistors over here will sometimes burn up. They do run hot. This one looks pretty good, so we'll see where we end up. I'm going to replace the film caps. If I cannot get the glue off of them easily without adding heat, and we're going to measure them too just to make sure they're okay. I'm also going to flip this heat sink around because there is no room for these film caps to sit flat. Like you can see, they're installed on an angle. Well, that's because there's a screw sticking out and it won't let it sit straight. So if you flip this around, it actually ends up being quite nice. That's the diode bridge anyways. You don't need a terrible amount of cooling on that. It doesn't get that hot. Alright. Gotta heat up that new tip. This glue here has got to come off too. At least off the board. You can leave it on the current limiters, but it's got to come off the board. And especially down here by this little ceramic cap. It's a common place for these guys to short is to the legs of these resistors right here. And that's having this glue here actually is a fire hazard. I've seen a couple of boards where it'll just sit here and arc between the leg of one of these resistors and the glue. I mean, fiberglass really isn't that flammable, but I don't know. There's stuffing and all kinds of other stuff inside these speakers. I wouldn't want to chance it. Alright, I am going to pull the 4 film caps out. Always helps to put a little lead on them too. Like, look at how nice and clean that came out. I didn't even have to, yank on it, pull on it. Just throw a little bit of leaded solder on the legs. Get them preheated. Break the glue joint if you can. Get down in there with an X-Acto knife or something and just separate it so the glue is not. These ones are actually pretty nice. There's not that much glue on them. I've seen them so much worse. Just buried in glue, so this one's really not too bad. But we'll take them out, we'll measure them. If they're within spec, the film caps generally stay within spec. If they're not within spec, then chances are they're going to swell up and start smoking. Nice chunk of glue. Now this is just the way I do it. It doesn't have to be done this way, but I think it makes for a nice repair. Everybody's free to do, whatever they want on their own device, but it seems to serve me well doing it this way, so if you want to try and do it my way, hey, go for it. So I'm going to actually pull the bridge out so I can get to the screw. And I'm not going to pull it out with this tip because the legs are too big, so we'll come back to that one. But I did put some fresh leaded solder on there. So I'm straightening the legs out, and I'm being extremely careful when I'm pulling these out to make sure they're loose. I do not want to damage any more of these through holes than I can. So this is a UVR, and these capacitors are okay. They're not bad. It's just not what I use. I usually put in the UPS series. I like them better. I think they're a little higher rated than these. Yeah, this is only 85C, so the UPSs are 105C. So you get a little bit more life out of them. Are these good enough? Yeah, probably. But this is one of the areas where it is a little higher heat, so we're going to do it that way. And I'm also going to double check all the values too. I have my junkyard board over here just to make sure. I know that the one behind the control board is 47 microfarad. I just want to make sure that the rest of these are what they're supposed to be. So it's a 22. And hopefully I have everything I need. I did just order parts, so we should be fully stocked up. So yeah, the UPS series is 105C rated. Just a little bit better cap, that's all. Nothing but the best. You send it to me, you're going to get the best. You're going to get whatever I put in there that makes it never come back to me again. That's the better way to put it. Alright, the square pad is usually the positive. These are all also marked negative, so make sure your polarities are correct. I'm using a thinner solder so I get a little more flux in there. I do want it to wick up to the top. Make sure we get a good full joint in there. Alright, one down. I'm wiggling these a little bit as I'm sucking the solder out. I want to make sure that the legs are moving and free, and it looks like this pad is weakened. So we have to be careful. Yeah, this pad did come loose. So the trace is on the bottom side, so we're going to leave it as is. I'm going to solder it back on, and then we're going to hit it with some new solder mask. But again, this is why you need a solder sucker. If you're going to work on these things, you have to have a solder sucker. If you don't have a solder sucker, you replace through holes and pads, and you have to do jumper wires and all kinds of other stuff. Don't do it. Buy a solder sucker. And I'm not really happy with the way that this one looks, so I am going to end up wiring this one. This is kind of one of those critical caps where if this guy doesn't work, your amplifier doesn't work. So the through hole is still intact because it did wake up to the top. I'm not quite sure if the pad just detached. There's no connection on the top side. So we might just be able to get away with tinning the trace. And this is an effective way to just sometimes make a connection a little bit more robust. Euro Tool fiber scratch pen. Doesn't have to be Euro Tool, but these ones are pretty darn good. I need to find my little brush. So you can see, kind of, yeah, there you go. Nice, shiny, clean copper trace. All the way from the leg of the cap to the board. So we're just going to thicken that trace up a little bit. Make sure it's clean too. You don't want to put solder over solder mask. It's a terrible thing to do. Nice and clean from point A to point B. We'll take our small solder, and we will just go over that trace. And all that does is just add a little bit of meat to the trace, just make it a little bit stronger. Since the pad was lifted, I don't want to take any chances. And we have continuity, so we're good. Alright, 2 caps down. If I remember, the first 3 are 47s, and the next 2s are 100s. And they are. And these are the ones with the bent leads. We're going to cut them out. I don't want to chance it. Plus I don't know what these top traces look like. Can also wiggle and break them out too. Takes a lot longer, but sometimes is necessary if you can't get down in there. Of course this one's not going to cooperate, but we have one leg cut, so maybe we can just get this guy out with a little heat. Let's see. Yep. Alright. So normally before I solder the new caps back in, I'd give it a really good cleaning. But because I am not certain of the condition on the pads and on the traces, I'm going to forego that cleaning because I don't want the fibers of the Q-tip to catch any of these pads and rip them off. So as long as you have, you know, a little bit of flux on there. Actually, you really just need the flux in the solder, but you can add some flux too. You don't need too much. But a little bit of flux will, you know, eat through that old flux, give you a good solder joint. And then after you get it soldered back on, you can go back and try to clean up the board. We want to do a minimal amount of damage to this board. We want to do no damage to this board. Alright, 2 down, 3 to go. And I'm just going to keep doing them all like that. Cut one lead, desolder the other, pull it through. If you can cut them both, cut them both. This one I might be able to cut them both. Yep. If they're spaced high enough off the board, you can get in there. Sometimes you can twist them too, just to get a little bit extra under there. But cutting the legs is definitely better than trying to desolder them. And I didn't even touch that one and it's loose, so we're going to have some problems there. Pad is gone. Nope. Can't wet them all. So we got to do a new pad and we have to rebuild that trace. So we have 2 traces on that side to rebuild. Let's clean out the last 2. I see another through hole that's bad. We're going to have to fix that one too. Whoever did the work on this amp, I applaud your attempt, but you definitely wrecked the board trying to replace the caps. And again, all that through-hole damage is avoidable if you have one of these. Weller solder sucker. I'm not sponsored by anybody. I'm not, you know, I don't get any deals or anything. I just like these because they work. I actually use one at my job, and one of the techs was using it, and I got to talking to him about it, and he said, "Yeah, this thing works great." I said, "Oh, let me try it out." And I tried it out, and I loved it. And I went out and bought one the next day. Made my job way easier. So seeing as we already have a ton of missing through holes and pads, we're going to clean it and see what we got. Can't really get much worse from here. Trace is gone. So I'm just really lightly just kind of getting it wet, going over the top just to get some of the gunk off. Then I'm going to come back with the Euro tool. That pad's gone. Man, we're going to have to redo all of these. It sucks. I'm just going to come through and get everything prepped for the new traces to go on. And whenever I do a trace, I always do the full trace. I don't just do the section that's bad. I go from point to point and replace the entire trace. Takes a little more time, but you end up with a better repair. I'm trying not to get my head into the camera. I know I need a different angle. Let's try something different for a change here. Let's go to this guy. And yeah, that's no better. I'll get a different camera and we'll try and see if we can get like an angle shot coming in for when I'm working on some of these detailed things, just so you're not looking at my head the whole time. It's kind of hard because I got to see what I'm doing at the same time when I'm trying to get down in here. I'll add that to the list of improvements. Alright, one trace cleaned. This one looks like it's completely gone too. Yeah, I'm just gonna pick them off. It's bad. See if I can leave a little bit there just to catch the legs of the, or the edge of the new trace. Now this one's a little bit different because this goes through and it weaves around the legs of the FET. So if you're not good with your soldering skills, or you're not comfortable making a patch going through there, you can go point to point on something like this. You have to use an insulated wire, and let's see. Yeah, you could go from this leg here to this leg and leave the FET legs intact, so in case, actually those are voltage regulators, but leave the legs of those intact in case somebody ever needs to pull that device out. Chances are that'll fail before one of these do. So this is just a filter cap for that power supply. So what I'll do, I'm going to clean the trace anyways. That'll be a game time decision whether or not I do the entire trace to factory or put a little jumper wire in there. You can, and the best way to do it is to use a 0 ohm resistor. I do not think I have any of those right now, so I'll just use a little piece of insulated wire. I use silicone wire, so it's high temp. And then I'll cover it with some epoxy. So this pad and through hole is completely wiped out. This guy's gone. You hate to see an amp come like, you know, in this condition to you, but this is you know, if you did this for a living, this is what you're gonna have to deal with. Like these amps come in all different conditions, and I've seen a lot of them in all kinds of different shapes, so I am not over or underwhelmed by seeing this. Now, if this wasn't so late, what I actually would do is I would take this board outside, and I have a sandblaster that I run cooking baking soda in. It's just a little handheld one, and I would actually sandblast this entire area with cooking baking soda. Don't use baking soda for soda blasting, it's too coarse. But if you use baking soda for cooking, it will take all of the solder mask off all these traces and it won't damage the traces. And you could do the whole area in one shot. But it is, well, it's actually not too late, but I'm still not going to do that because it's dark outside and I don't feel like dealing with it. So for now, we're just going to keep cleaning the traces. And I mean, it's not too bad. The Euro tool does make pretty quick work of it. I mean, I know it doesn't look like much now because the light is not cooperating with me, but it looks pretty good on my end. Tell you right now, though, this goo is going to have to go. Once that gets impregnated with fiberglass dust, it's going to be a nightmare to deal with. Alright, 2 of the traces are done. You know what, we'll do this entire trace here. And if you're a little bit sloppy and you get some of the mask off some of the other traces, that's okay. It's not going to hurt them at this point because we're already in there and we're already taking all the mask off anyways. This is going to have to be recoated. You can coat it with epoxy. That's the old way that I did it, or you can coat it with solder mask repair. That is the new way that I do it. Either one I would say is acceptable. One thing about these tools, you can't let the little fiberglass insert stick out too far. If you do, it just kind of frays. You don't get real good cleaning action. It's kind of just like they're using a pencil eraser and I'm just erasing it off. Next time I will not do that by my workbench because that made a cloud of solder mask. Note to self, do that in the other room. Alright, so we have this trace here is good. Missing a through hole. This one is missing the edge of the through hole, but it still looks somewhat decent. It's just like the tiny little edge. This guy here, he continues all the way to the front pin on there, so that's quite a ways. We got to get that all cleaned up. And the last two actually look okay. I'm still going to pop a new through hole in them, but I'm going to leave those traces alone because they look alright. So we have 1, 2, 3. We have 3 traces we got to rebuild. Right at the end of the world. Seen worse. I'll make a note to myself though, so when I do work on another one of these and I actually sandblast the solder mask off, I'll make a video of that and show you how I do it. It works really well, and it doesn't damage the board. I tried using an actual sandblaster, and yeah, it totally wrecked the board. It was just, the grit was way too much, and it just chewed right through the copper and right into the middle of the board. Luckily it was a garbage board that I was just trying it on, so I didn't really ruin anything. But lesson learned, don't use glass beads and don't use blasting soda to clean mask off a board. Cooking baking soda works wonderful. Alright, that trace is good. This long one here, I'm going to continue cleaning him off. So I have one of those solder mask kits, and the solder mask hardens from UV light. And I got it at the Rossmann store. Louis Rossmann, he does MacBook repairs, and I like watching his videos, so I figured I'd support him a little bit and buy something from his store, and it actually benefits me, so hey, good for him and good for me. Haven't really tried it yet on a board, so it'll be interesting to see how it works. So we'll do that instead of doing epoxy today. Plus it has that nice green color, so it'll actually look like it's supposed to look. Alright. That trace is somewhat clean. That one's good. We got one more little one here. If you have legs that are on a not bent and they're covering one of your traces, just take a pair of nippers and just lightly bend them out of the way. If you can get to them. If you can't get to them, use the solder sucker, desolder it. Actually, I need to turn my solder sucker off. And my iron. Desolder, just so you can get all the mask off. You want all the solder mask off if you're going to be redoing one of these traces. This area in here, it's a little too tight for the Euro tool. So I'm going to go in with a wire brush and get the rest of it. Little brass brush. It may or may not get it all. And this one's being difficult, so we'll just go in here with our X-Acto knife and scrape the rest of it off. You can go in there with a small flathead screwdriver. I mean, really anything. You're just trying to get the mask off, just so you can run a bead of solder down there. And actually, you can take the scratch pen and stick the tip way out of it until it starts to flare. And you can get in there, but that does ruin the insert that you have in there doing that. Alright, I'm going to go brush this off away from my desk into a garbage can. Put down a new working sheet. It seems like it doesn't fail no matter what I do. I have to clean my little silicone pad here after every repair I do. So there we go. Let's see if I can get a good view with the light. And probably not, because it's kind of reflective. Nice clean traces. Actually, it's better with that guy off. Nice clean traces. The board's a little scratched up. Haze, it doesn't have that like nice shiny look to it anymore, but there's nothing you can do about that. So, let's put some through holes in. We haven't done this yet. I got this kit from solder.net. There you go. It comes with a bunch of different sizes. I don't really know what these numbers mean. I'm sure that has to do with the size, but that's a stupid way to number them and say what size it is. I'm not a fan of that numbering scheme. So I have these labeled. I wrote on there best fit. These are the ones that work good for Klipsch boards. I will drill these out. I normally, oh, actually, hold on. Let's rewind for a minute. I do have some of the medium size that I might be able to get in there without drilling, or with minimal drilling. We're going to try one of those first. And the reason is if there's anything left inside the original through hole, it'll stick a lot better. Not that it needs to, but the legs of the capacitors will still slide through these. There's one size that does fit the original holes. That sucks. Just shot off like a rocket. I know what's going to happen now. We're going to be one short. So that's going to be hard to see. But let's zoom in and not lose this one. That is a through hole repair ferrule. It's just a little sleeve. Let me see if I can get a bigger one. I don't know if you can see in there. I don't want to pull them out, but it's just like a little cylinder with a head on it. And you drop it into the hole, and then you form the head on the other side, and you have a nice new through hole. They work pretty good. Takes a little bit of practice to become decent at doing these, and I'm by no means an expert. So let me grab one of our capacitors. The legs slide really easily through this one, so we can use this through hole to repair this just fine without having to chew up the inside of the existing holes. And we might have to ream them just a little bit, and that's from residual solder that's in them. So we'll find the mating drill bit, which I believe is going to be this one. I need a way to mark these. So it fits through almost all the holes except for one, or two. That's going to be too big. The way this works is we're going to just clean out the holes, just run a little drill through them. Make sure there's no solder that's going to block it, or any garbage in there. I hear my dog coming. She still probably won't say hi to anybody. Alright, ream the holes. We'll check the front side. Front side looks good on all these, so all the pads are still there. Some of them are chewed up a little bit, but we will clean those. Actually, let's clean those now. Because some of them might not actually have pads on. First one is missing a pad. All the other ones appear to have their pads, but the reason why I want to clean the top side off real good is because when I hit this with solder, I want the head of the through-hole repair to have something to solder onto. And I will be right back, because my dog is walking on my new tile. Get over here. Come on. Come. Sorry about that. Can't have the dog going rogue on the new tile though. So when I put the new through holes in, I put the factory side on the side that has the connection. So you drop it in. There's two pieces to this. There's a little spring-loaded punch. Then there's a tiny little, I don't know what the heck you'd call it, reamer. Then you have this guy, I think this is the anvil. Like, you get it set down into the hole. Then you line it up with the little head of this thing. That's not going to be high enough. Heat sink is just a little too big. So you line that up so that it's sitting on something and somewhat supported. You take the little spring-loaded. In this case, it's like a spring-loaded center punch is basically what this is. I don't really use the center punching action of it. I find it's better to just kind of get in there and just work it around, just kind of wobble it. And then once it's formed like that, you can go ahead and punch it. But I find that the punch sometimes causes them to tear. So I don't really do the punch too often. And then after it's formed, I take the end of my X-Acto knife and I just flatten it out. So there's one done. And then I'll take the little pointy one. This is for forming really, really small ones. But I also use it just to kind of stick it in there and make sure that the hole is holding its shape. So we will do the rest of the ones. Actually, I'm just going to do them all. We'll do all of these. And I'm running low on this size, so I'm going to have to order some more. It's pretty rare when I have to replace the through holes, but it does happen from time to time. This one has the trace on the bottom, so we're going to put the factory head on the bottom. We'll check up top, and the up top is just a pad. So you got to be careful though when you're forming this. So if you're careless and you form the head too large, it could actually cause a short. So when you're flaring it out, you want to make sure that you don't flare it out too much to where it's going to be larger than the original pad. And if you think it will, flip it over. Put the form side on the bottom where the connection actually is, because then it doesn't matter. So you can also, and I've done this before, you can just form it and leave it kind of coned up a little bit, and then that'll fill in with solder. And that makes a perfectly fine through hole as well. I'm sure there's like codes and standards and specs and, you know, all kinds of things for doing like an industrial grade repair, but you know, I'm not certified, so I don't care. I just want it to work and I want it to last. Those are my two criteria. Now, if this was going into like spaceships or, you know, something crazy, then yeah, I might try to do it a little bit differently, but you know, just flaring it out, making sure that it's clear, That's a good repair. So this guy, the connection is on the top. We will go from the top, and we'll insert him with a little poker. If I can get it on there. And these things are small. They're hard to hold, they're hard to handle. So just for the heck of it, I'm going to leave all these flared. You know, they're small enough to where, you know, the edges do split when you smash them down too much. You can put them down a little bit. Use a piece of plastic, something soft. I used to have a little piece of plastic that was on a paintbrush that worked rather well. Little rounded pieces of metal works too. I mean, you can flatten them out a little bit. You don't have to crush them all the way down. It just really doesn't matter. What matters is that you get a good electrical connection. You actually have a through hole. And, you know, it's not going to fall out. Oh, my dog is back. Does not want to say hello. She's mad at me because I kicked her out of the new room. Alright, 3 down. More to go. Again, we're doing the sides that have the connection. If the connection's on both sides, you can pick whichever one you think is more important. I gotta actually clean up that trace too. I missed one. Luckily, like by magic or, you know, something, this board, even though the board is not in the best shape, it does not have thermal paste all over it. I would much rather have a board that's messed up than have to deal with thermal paste. I will take that any day of the week. So here, okay, this guy connects on both sides. So the bottom side has the pad kind of ripped off. The top side looks like it's a ground connection. So, I'm going to put the head on the bottom side on this one. Again, you could do point to point on these if you really wanted to, but I just don't think it makes for a quality repair when you just got a whole bunch of wires running around on the bottom of the amp. Like, yeah, that's the way they used to do it, but I think you have a much higher quality repair when you actually, you know, take the time to redo it like it was originally done. Plus these things are in a fairly high vibration environment, so it's probably in best interest to make sure that parts aren't just floating and flying around in there. These are just filter caps for the low voltage power supplies, but I still would think that it would probably cause some sort of hum or some kind of adverse side effect if one of these caps came loose. This guy does not want to go in. still a little flux on there from the old caps. Let's re-drill that guy. Oh. Let's try the other drill bit. I think that's what it is. We're using one size too small on the drill bits. Hopefully I didn't just blow in the microphone. If I did, I'm sorry. Too lazy to hit the mute button right now. I just want to get these in and move on to the next step. Still fairly early, so we should be able to at least get this guy done tonight. I wanted to get into a different style of amp. I know I have a couple of people that have been asking about doing like some sub-10s or, you know, something different. All I can say is we'll get there eventually. I'm hoping this week I can spend a little time doing a few more of these, because I just have some stuff I have to get through and get done, so I'm hoping. And this guy split even without snapping it down, so these small through holes are definitely delicate, and they're even worse from the factory. The factory, it's just a plating. This is actual like metal going down into there. I believe they're made out of copper and then plated. This next one is top connection. So it will go from the top. And I'm going to double solder these. I'm going to solder both sides, which means I'm going to do one at a time, and I'm going to space them off the board. I want to be 100% certain that these things are in there, and they are in there well. Keep getting off camera. Sorry about that. Next, got 3 more. This guy is bottom connection. Goes to this trace right here, which comes up and around. And I will add some 0 ohm quarter watt resistors to my. Actually, I'll probably do a little bit larger. I'll probably do half watt, because I believe they're a little bit larger than, or I mean, they're a little smaller than standard resistors. Half watt is about the size of what quarter watt would be. Something like that. I'll have to look into it. But whatever one is the size of a standard quarter watt resistor is the size that I will order for making jumper connections. Again, that just looks a little bit more factory. It's not needed or There's no requirements for it. Okay, this guy I gotta clean the mask off of again. I missed 2 traces apparently. Man, that one really doesn't look bad. I want to skip it, but I'm not going to. It's a pretty short trace too. Does have a couple legs in the way. We will bend those up. We're not cutting them. We're just using the cutters to get a good grip on them and bend them. And again, this board would have been a great candidate for blasting. Seems to be most of the power supply sides are where you need to do that. After the FETs have been replaced a couple times, somebody's been messing around in there and they get pretty gnarly. That's typically where I'll do that. But for something like this where you kind of have a lot of trace work to do, it's just to save some time. And it's a lot less mess too because I do it outside. And since it's baking soda, it's like environmentally friendly and it just washes into the ground. I don't know if the solder mask is environmentally friendly, but the tiny little bit that is discarded, I don't think is a big deal. And if it is, I'm sorry to the butterfly that lands on it. Alright, this guy. This trace right here is probably going to need a full rebuild. I know it's hard to see. There we go. But there's such a large gap in there, I don't think the head of the through hole will make it to both sides. If the head of the through hole covers the trace on both sides, I would solder over it. But if there's, even a 1,000th gap, that's not good enough. It has to be 100% continuous. Just a little bit of thermal stress. Would actually be enough to cause that to fail if you had a tiny gap there. And that would be a problem. That would be extremely difficult to find. Like, if it came back to me or the next guy that was working on it down the road, had to try and find that, and it was hidden underneath a through hole or right next to a through hole. I mean, that would be a nightmare. I would not want to do that. So if I'm not going to do that to myself, I'm not going to do it to anybody else. Curious if any of the main FETs are blown. They are fully intact. The gate drive resistors are fully intact. I'm wondering if this would be the first time if all 4 of these FETs were good and nothing was wrong there. That would be a first. I've never got one that has had any sort of damage where one of these was not blown. I knew it. I was going to be one through hole short. Oh, I have more in the tube. So we'll finish this up. I will redo the caps one by one. We're going to double solder them. And then after that, we're going to switch to glue removal. Well, this one was kind of... Yeah, this one's kind of loose in here. So that one's really no good. So what I'm going to do is I'm going to go up one size on the through. So we'll go to the best fit. We need the large ones to redo the cap through holes. That'll be next. Best fit. I used to have all the drill bits organized with these things. I wish I still did. I'm going to have to go up and get my calipers because I know I don't have the proper drill bit for the large one. Add that to the to-do list as well. I need to make sure that I'm using the right size drills for these. I should 3D print a little holder so I know which bit goes with which size. Alright, last one. And he goes in through the bottom. Actually, going with the larger through hole. Let me lift that up to verify, but I think... Oh, we're going to get lucky. We are going to get lucky. Alright, well that's going to save some time then. Cool. So going to the larger through hole, the head is big enough to where it overlaps the trace on both sides, even though there was a decent sized gap in there. I'll call that a win. It's one less trace we have to repair. That is cool in my book. Again, I'm not snapping these, even though it's the bigger one. The little cone that it leaves, even if it's not flush with the board, actually gives you more surface area to hold solder. And once it's soldered in, it's not going to go anywhere. I mean, it's already, it's flared enough to where it's going to hold in place. Okay. 10 through holes. That sucks. And more to go. C12, C17, C22, 47 microfarad, 50 volt. That's the top three. Space them up. They don't need to be too high off the board, just high enough to where I can get the iron in there and get some solder on them. And these things draw in solder really, really nice. So the solder is actually wicking up to the top, and I'm not having to hit the top. Sometimes you do, sometimes you don't. Make sure you check your polarities on this. The first 3 are all the same. The last 2 are reversed because that is for a plus and minus supply. So on the ones where they are going to a ground on the top, I am going to hit it. And I'm doing that because I want to make sure that the solder does flow underneath that top pad. That is important. Hit it with a little flux. Make sure it flows. You want a beautiful fillet on that top part where it's making contact. The bottom we don't care because it's not contacting anything. So this one here is going to get that treatment. And I think that is it. Let's do a quick continuity check, and that will tell us. Actually, this one. Yeah, so 1, 2, 3. So we have 3 that we need to top solder. The rest of them are behaving quite nicely by themselves. I'm making sure that I did not miss any traces. I thought I missed one earlier that I still needed to clean up. I'll look again in a minute. We want them to be kind of straight, double check, make sure they are, make sure they don't look kind of crooked or weird. Make sure we get nice fillets. Alright, next to 100 microfarad, 25 volts. Let's check our reference. I believe they're 25s. 25. We are in the clear. Let's make sure I have them. I do. I have plenty. And this is the one where the polarity switches on these two. The first one, the negative goes towards the outer edge of the board. The second one, the negative goes to the inner edge of the board. And I found my trace that I need to fix. So the via that is on the negative side on this one needs to get top soldered. You only have to do this once. Like if you were to repair this board again, you wouldn't really have to do this because if you suck the solder out, it's not going to suck it from inside the through hole. So you only have to do that once. But this should be a 30-year repair. If you unplug it, you turn it off, don't leave it on 24/7. These caps are going to last a long time. That's again why I prefer the PS series over the VZ. I used to use the VZs on a lot of stuff, but and sometimes you have to. Certain values are just not available in the UPS series on these. So you gotta kinda just do your best. I don't like that joint. A little more flux. Perfect. Alright, now we can clean up the top. I don't really care about the bottom at this point. We'll get to that. I'm going to zoom out. Make it a little easier for everyone to see what's going on. And I'm just getting in here, just getting some of that flux that I added off. You don't have to do it, but it doesn't hurt to just give it a little wipe down. Just makes it look a little better. Alright. Snip the leads, and then we're going to start buttering all these traces with a little bit of solder to start rebuilding them. Okay, leads are trimmed. Let's clean off. Clean off a little bit of the flux on the top here. Get ready to rebuild the traces. I still have that one trace I gotta get the solder mask off of. That I've actually, yeah, this trace right here. Just needs a little bit more of the solder mask removed. Sometimes it's hard to get into these leads to straighten them out, so a flat blade razor like X-Acto knife works wonders. And I have a bunch of different sizes of X-Acto knives, but if you take this and you put it under all the leads and just fold them up, they will all fold at the same time. Don't do it if there's a trace underneath them though. Like if there's a trace running by, don't cut the trace. And that's exactly what I'm telling you not to do, but I'm doing it right here. But the only reason I am doing that is because I'm being careful and we're taking the mask off and redoing that trace anyways. Alright, let me clean that off and see what happens. So just for the heck of it, we're going to check continuity on one of these that I think is tucked under the pad, but I want to make sure. So if we got connection point to point, we will know that we're good. So we have we do from one of them, but not from the other. I can't tell if that's actually not connected or if it's just not smashed tight enough to where it's touching. Magnifying glass says it's underneath there, so we're going to go with it. Alright, now to fix these traces, we still have this guy to deal with that's burnt. I'll show you what we do with those. These ones luckily are not burned. So on all of these that we scraped off the solder mask from, we're just going to go from point A to point B with leaded solder. And just give them all a coating of solder. And this is just going to eliminate us from having to do point-to-point repairs. You know, little areas in between things where they look like they're close or touching, you know, it doesn't hurt to double check those either. You could throw some, if you're not getting a good flow on the trace, you know, throw a little flux down, throw a little more solder down. You just want it to be tinned from one connection into the other. And we'll go through with a meter and check them. I'm actually going to do this one that goes through the voltage regulator. I know I said I was going to do a wire, but It's in good shape. I'm just going to run it. Now when we get in between the parts, you're going to be a little careful that you don't solder bridge it. Best way to do that is to throw some flux on it. So you can see I did bridge it, but now since I have some flux down on there, I'll just take the iron. And of course it's not going to cooperate because I don't want it to, or because I want it to. All else fails, get the solder wick if it's being a pain like this one is. I'll check to make sure it's not shorted, but I'm pretty sure it's not. Alright, let's continue. So we're ending up with a few bridges when I'm passing in between some of these other through-hole parts, but we're gonna check all these and make sure that they're happy. Just throw some flux on there. We'll clean off the flux later. We're interested more in having good solid connections. Than we are about looks right now. A little bit of alcohol and a toothbrush will take care of everything else. And again, this is all 100% avoidable if you use a solder sucker. A good solder sucker, a vacuum powered solder sucker. And I'll try and get a close up after I get this all cleaned up. So if anybody has any suggestions on how I could run like a detail camera that I can get a good angle on so you can see what I'm doing, please let me know. Like, I haven't quite figured that one out yet. But I need it to be in front of me. It can't be above me, or I guess it could be from the side too, but it might give a weird view, weird angle. This trace is going to be kind of difficult because it weaves a lot. But I'm doing the whole thing, point to point. Doesn't really do a whole lot. I'm going to change tips. It doesn't do a lot of good if you just do part of the trace. I mean, I guess it's better than nothing, but to me that's just doing a half-assed job. Smaller tip will give us a little bit more control just for kind of painting in this trace here. Sorry for blowing in the mic right there. I'm not used to having it in front of my face still, as you can tell. I will mute it if I do that again. Alright, we did bridge on this connector here, so I'm just going to take some of that off. Usually a quick flick with your wrist is enough to take a solder blob off. So if you have, especially if you have enough flux. The smaller tip's actually working pretty good, so I'm going to go over some of these other ones that don't look as nice. Just go over them all one more time before I clean it up, then I only have to clean it once. I'm not terribly concerned with not having nice fillets on the bottom of these parts here. Generally I would be, but right now I'm more worried with having connections that are reliable. I'm lucky there's no ground planes under these, because if there were ground planes on some of these, I would not be able to use the smaller tip. I wouldn't be able to get enough heat into it. Alright, I think that's going to do it for this. At least for this section. What a pain that was. Sad part is we haven't even gotten to the repair yet. We're just re-repairing the repair. But I think this is a good example of what to do if you do encounter a board or something that somebody else has worked on. You got to check their work too. I make mistakes, everybody can make a mistake. When you miss something small though, that's when it becomes difficult, because then you got to try and figure out what it was, what caused it. So we'll get a majority of the flux up, and then I'm going to hit it with a brush. And I'll be honest, I have no clue where my brush is. It used to be on my old bench, sitting in a can. My old bench is no longer. RIP to the old bench. And all of my tools that were organized on it. Everything is kind of scattered about in the new little work area here. We have the technology to make a new cleaning brush, though. Oh, I got lucky, I found it. Like 59-cent chip brush with the bristles cut down. And some alcohol. A few spritzes and a few scrubs. So I'm just kind of getting some of this flux off of here. And I know you can't see me right now, but I'm working over a garbage can. Because I don't want that stuff all over my desk. Alright. Let's see if I can show you guys what that looks like now. Yeah, that's pretty good. It's kind of like factory new, I guess. In a way. I don't know. Good enough for me. I'm happy with it. We're going to do a little point checking. Check for some shorts. Make sure that the things that are close are not shorted out. Make sure everything is connected where it is supposed to be and not to anything else. Alright, that is good. All of those traces are back to normal. Now, I'm not going to coat it yet. I'm going to leave it uncoated. I want to make sure that, you know, I don't have to go back and touch anything up before I get into any other part on this amp. So I think what I'm going to do next is rebuild this trace that goes from the negative side of the capacitor into the bash control board. So this trace is completely melted off. So I'm going to run a wire to redo this one. And what I do is I try and leave as much of the original one there as I can, because I use the old trace as kind of a tacking point. And again, you can go point to point, and eventually when I get some... Wow, this thing is really cooked off this board. I'll get some resistors to go point to point, but for now we're going to do it the way that I'm used to. So I'll get a thin piece of magnet wire, and I will trace it down along the original path, and as I go and bend it where it originally was bent, I will super glue it in place. Is it necessary? Probably not, but it makes it easier for me to follow what I did it's out of the way. Now for this one, I'm not going to clean the whole pad because that's a huge area. If I was using a blaster and blasted it, I would do the whole thing, but since I'm just doing a track repair, I'm not going to do it. But I do go over the whole area even where the original trace was pulled off. And the reason I'm doing that is because I'm scuffing up the board and giving the super glue somewhere to grab onto. You can be kind of messy with the scratch brush, it doesn't matter. Like, we're just trying to remove this so we can see what the heck's going on. It looks like multiple things connect to this pin. I really hope the dashboard isn't messed up, especially if we have to replace this. That would suck. And the only way we can find out if it is when we get the power supply all finished and ready to go. There are no shortcuts in this, at least not that I've figured out yet. Alright, let me clean this off. We still have the large through holes to touch up. That's coming. Actually, I want to, while I'm thinking about it, let's see if we have any shorts on the FETs. I can't believe it. They're all going to be good. That is hard to believe. That's a rarity right there. All of the original power FETs are still good. So what must have happened is something with the glue shorted on this side, and it caused this FET to turn on. Turned full on, probably stayed on in blue, and then cooked everything behind it. We'll get there. It's going to take some time. We got to fix all this other stuff first. Alright, I am going to start working on these other through holes so I can get all my through hole stuff put away and off my bench. So that's kind of making a mess right now. And we'll do all 6. As much as I don't want to do it, we're going to do all 6. I do not remember what drill size this is, though. I think these are all too small. I need to get one size larger on these. These snap-in style caps, the legs do not fit nicely in these unless you straighten them out. I mean, they fit, but it's going to be hard to see. But these caps have like a little hook on the end of them, and they're meant so when you pop them into the board, they stay there. But when you're doing through-hole repairs, they do not fit. At least with the stuff that I have. So my solution is I just take the bend out. I know that doesn't help them hold into the board as well, but I silicone all the caps into place anyways, so I'm not terribly worried about it. If you're doing something that's going to actually knock a cap out after it's been soldered in, you're doing something wrong anyways. So we'll get those 3 repaired, or straightened out and ready to go back in. Prepared, not repaired. Alright. this through hole is completely gone. There is nothing there. This guy is somewhat intact, but we're going to do it anyways. The tops of this look okay. I'm going to hit them with the scratch pen just to kind of brighten them up a little bit. And really the only reason for doing this is just to make sure that I get a good flow of solder on. And I'm actually going to put both of these in through the top because I want the cap to sit down nice and flush to the board. Just a little prep and these things will stick on there real good. Same with this bottom one. I'll just shine it up a little bit. And that's more than enough to get a really good solder joint. I might get lucky and these will fit in the original holes without having to drill them. I'm hoping that's the case because I don't know what size drill bit these use. And I don't want to go upstairs to get a micrometer to try and figure it out. And they fit. I got lucky. And if two of them fit, that means all of them will fit. I'm still going to flare them out. You can get away with not doing these because they're so large. But since the caps will no longer snap in, I'm going to flare them out. And we lost one. I am not surprised. These you actually have to put a little bit of muscle into to get them to flare. I might actually snap these. Again, I'm not gonna fully smush them down to the board. I'm gonna leave a little bit of a raised cone on there, and that's gonna help hold solder and make a good joint with the pad that's below it. There's the one that fell out. So this one, I'm going to do it the opposite way, even though I said I wasn't. And I want the good joint to be on the top. So I might have to, I'll test fit the cap. These do have a little bit of room underneath the base of them. So if I have to smush it down, I will, but I want the cone on this side so I can get solder under there. This side of the board is really chewed up. Must have taken a blowtorch to it to get that cap out. I don't know why that would be that chewed up on there. Give a little light. There we go. I may have to ream those a little bit to get the leads through. Actually, we can just do a test fit right now. It's... no, they're not going to go in. I'm going to have to ream them out a little bit. Or not ream them out, but like wallow them out. It's interesting, they don't give you a reaming tool or a pointed tool that fits the larger ones. Fits all the smaller ones nicely and opens them up, but doesn't fit any of the larger ones. Gotta kind of make it do with what you got. Alright. Two very good through holes. Now this one I'm going to do something a little different. I'm actually going to solder it, then I'm going to clear the hole. So I got to turn my solder sucker on. But I want to make sure that I get full penetration all the way around this through hole with solder. There's nothing on the back side, so your connection is only on the top. I need a really good connection on the top. This one, it doesn't matter. That one I need a good connection on the bottom, and since we have the little raised edge of that through hole on there, that should be just fine. Alright, iron is hot. I'm using a thin solder because I want pretty good control. Actually, I got the wrong tip in there. That ain't gonna work. And I dropped my tip, so that ain't gonna work either, probably. We might have to throw some flux in there, but since we did a good job cleaning it, we might get lucky. I'm heating one side, and I'm trying to get it hot enough to where the solder will flow without filling the hole. Alright, man, we got it. Now I'm going to take the solder sucker, hit the center of the hole, and clear it. And that's a really good connection. I'm not going to put the cap in yet because I still see we have glue to clear off, so we will go, well, let's do that now. Let's clear the glue and put the new cap in. Hot air, 120°C. Gets this stuff softened up and ready to scrape on. We're almost there. Whoever was doing this, I mean, they did a good start, but they just didn't drive it home. So they left some residue on the board, which means that they weren't hot enough when they were pulling it off. So we'll do whatever we can to get that remaining nasty glue stuff off. Dental picks are going to be your friend here. You can see some areas, like in between these two ceramic caps, it's almost got a little black to it. So I would say that this was probably pretty close to failing. All this glue has to come out. If you don't get all the glue, you're going to be doing this again, because new things are going to blow up and then you're going to be upset. Do it all in one shot. And you'll be alright. Ooh. Yeah, watch your fingers too. It does get hot. Stay away from the film caps. You don't want to heat up the film caps unless you absolutely have to. We want to get the glue out, but we don't want to damage the film caps. If we do damage the film caps, we have replacements, but it's one more thing we need to do. And once you get a little heat on this glue, it does come off pretty nice. Some of it, if it's charred and crispy, it's a little more difficult. You can always turn up the heat a little more. This one's actually fighting me, so I think it is worse than we thought it was. underneath the legs of the resistors is important too. Don't just clean around them, like you have to actually poke through underneath the little leg of the resistor. All this glue has to come off. I cannot stress that enough. You have to get it all out. It sucks. It stinks. If you tear a little solder mask off, doing it, no big deal. Get the tip of your dental tool down in there, or pick, or whatever you want to use. Get that crap out of there. Because these resistors get hot, and what's going to happen is that glue is going to start to get conductive, and it's going to short that leg right out to the ground plane that's here. Then your amp's not going to work, and you're going to wonder why. I'd make a good dental hygienist. I'm pretty thorough with this stuff. Guess if my day job doesn't work out, I can always add that to my resume. Excellent with dental picks. I don't know if I'd want to work on people's mouths, though. That sounds terrible. Absolutely terrible. I appreciate the people that do it for me, but I would not want to do that. Alright. Shorts around these ceramic capacitors and around this NTC are very common. So make sure you do a decent cleaning there. Try and get it off of this little standoff too if you can. I know it's easier said than done. I keep replacements of those just in case like I get frustrated and I don't want to do it. I'll just replace the whole standoff, but if you can get the glue off, get it off. If you can't get it off the standoff, at least get it off the board. I'm going to replace this whole standoff. Alright. I think that hit the ceiling. Cool. Those standoffs, you get them in like 1,000 pack on Amazon for dirt cheap, so... Again, try not to heat these up too much. We're just trying to get the glue out of there. And we'll replace this glued connection with a silicone blob. Silicone is a lot more difficult to become conductive than whatever this crap is. Alright, we have a couple more glue spots to clear and the glue will be good. This glue on this other side of this guy is crusty. When the glue turns black, that's when bad things start to happen. Alright, a million times better. We have 2 spots over, 3 spots over here. You can take your flat blade X-Acto knife and use it like a chisel too, sometimes. you know what it's necessary to do just to get some of it off. Make sure you get by these resistors good. This is the one area where you don't want to skimp. And over by these NTCs. And be careful so you don't cut through the legs, but get all the glue off. Or as best you can. If you can't get it all, you know, it ain't the end of the world, but get it all off the board. If you don't get it all off the parts, fine. Definitely get it all off the board. You know, try to be nice to the board. If you scratch it up a little bit, you know, a few battle scars will be alright. So, over here, this you can leave. That's not going to hurt nothing. Over here, and over here, get the glue off. You know, the glue that's on the filter part over here, like in these things, that ain't gonna hurt nothing. You want to get the glue off where you have a big copper pad like this, and then you have like these bleed off resistors right here. You know, if one of these legs is a different polarity than one of these pads and that glue's on there, that's where you're gonna get a short. You know, over here, there's no plane. This is just circuit board. There's nothing to short out over here. So, you know, this little bit of glue that's holding these two components on, that ain't gonna hurt nothing. You'll be fine. Alright. Now we're gonna finish the through holes and then put the through hole kit away, because it is in my way. I'm gonna do actually no, that's the one I want to do from the bottom. We're gonna do these three from the top. I got lucky there, that caught it for me. 3 from the top, 1 from the bottom. So this guy is going to be on the top. We'll do one at a time so I don't drop them again. There's one. This third one looked like it had some boogers down in there. It might give me a hard time. Oh, that one was really loose. This is the largest through hole that I have, so there's nothing I can do about it if it's a little loose. I'm hoping that this one will be loose too, because that's the one that had all the gunk in it. I just tried to clean that up because there was a little bump on it and it just took the whole top of the pad off, so yeah, these were in bad shape. No bueno. Doesn't want to go in. Let's see if we can force it in. There we go. Good. Okay, and one from the top. Or from this side to the top. Okay, we're in good shape now. I am going to put the secondary cap in first. We'll solder that one in first, and then I will go to the primaries, and then we'll do the flip the bridge around and do the film caps. We have to measure the film caps first, but we will do the film caps next. This one's going to be a little difficult to get in because these through-hole repairs are a little bit small. I'm hoping that I have clearance to the base of the cap. And it is sitting flat, so we're good. So to solder these in, I'm actually going to use the solder sucker with the large tip. And I'm double checking my polarity. We're good. These are marked, but I usually look for the square pad, and there's no square pads because the pads have been ripped off, so you have to look for the little minus on the board. That guy's in. One more. Alright, they all fit nicely, but one of them is coming back out. And the reason for that is we're going to flow some solder around that guy first. And we covered the pad, but that's okay. So we're just, at this point, we're just going to hit it real good. Get it good and hot. And then I will heat up. Changing my tip. Make sure this thing's cool before you touch it. Done that before, that was not a good day. So the customer that sent this in, he was using, I believe they're LGN style. I mean, he's using a Nishon or Nichicon or however you want to say it. I like the GUs just because they're a little bit bigger in diameter. These work better in like the sub 12s. They fit the board size a little better. I like using the larger ones in here. And you can even go one can size larger. But it just makes, it gives more surface area on the board, so it'll be a little more stable. And then when you silicone it in place, you don't need as much silicone. Personal preference. It doesn't really matter which ones you use, but I wanted to double check any of the work that was previously done, and I'm glad I did because we had some torn out pads. So I think we're going to be in good shape. The heater in my solder sucker is starting to wear out. It takes forever to get hot. So we're going to clear it from the bottom. And the reason we're doing it from the bottom is because we want the fillet on the top to remain intact as much as possible, because that's where we're going to get our connection from. And all of these large caps they put in these boards, the pads are not solid. They use thermal clearance on them when they're doing the board layout. I guess it makes it easier to solder them in. So there's just 4 tiny little trace segments that connect to these pads on these large caps. So you need a good connection. You need a really good connection. I like using the large iron sometimes on these just because I can get a ton of heat down into it. And I know that I'm never going to have to worry about this connection ever. That is a million times better. Nice, clean fillets, good solder joints, new through holes. We're not going to have to worry about that. Alright, I will show everyone my bridge trick. I think I've talked about this before in one of my other videos, but so I'm going to give this a few wiggles just to kind of, any residual solder that's left on there, I'm giving it a chance to kind of clear itself and break off. These are actually a fairly tight fit. But if you do it right, you don't take any of the through holes with it. Just be patient. Like, that's a perfect desolder right there. No extra work. Except this one was glued on. That is extra work. Ooh, we're going to get lucky. It's going to come off in one piece. Nice. So like I said, this step is optional. I don't, really think it is 100% necessary to do, but I like the way that it turns out after you do it. So I take the heatsink off the diode bridge, flip the screw around to the other side, deliberately strip out the screw because it is tight in the plastic a little bit. It ain't gonna hurt nothing. Strip it out so it spins. And then you can put the heatsink either facing up or facing down. Today we'll face it up. We'll face it up and to the left. How's that? Now, if you really want to be here, we'll do it just because somebody's gonna say, "Oh, but it's not gonna have a good connection," or I don't know, for whatever reason. Let me find the stuff that I absolutely hate. And we'll put a little dab on there just to say we did. Dow Corning 340. That's the stuff you want to use. I use this on my PC heat sinks. I use it on my amplifier heat sinks. I use it pretty much on every heat sink. Like, you might get an extra half a degree by using Arctic Silver or, you know, some other fancy compound, but you know what? This stuff works pretty darn good, and it costs a fraction of the price. I mean, it's an industrial thermal compound. It's made for this. I used to be on the bandwagon of all the fancy, expensive, like, thermal pastes, and for what I do, like, it doesn't make a difference. And I hate this stuff because it gets all over anything anyways, and it's hard to clean up. I want to get it relatively tight. Doesn't have to be, you know, crazy tight, but like medium crazy. Medium crazy is a good tight. You want the heatsink to be straight as you can get it. And then we'll drop it down in there and see how it looks. And we're already going to have a problem. Now I remember why I laid it flat. And I also remember how I done it vertical. So we're going to redo this real quick. So when this layout was done on this board, and they decided to put a heatsink on this, there's a resistor that is unnecessarily placed right where the heatsink needs to go. And I typically forget about it, and it drives me crazy, and it's a pain. The only way I've found to nicely do this is I have to take my beautiful cutters and potentially ruin them by snipping a leg off that heatsink. I don't know why it has these little legs on it. But now, with that snipped off, I can lay the heatsink flat on the other side, and it plays nicer with that resistor. I forgot about that. If you want to stand the heatsink vertical on the back side, you got to move the resistor to the bottom of the board. And we can do that, but you get it as straight as you can get it. Doesn't have to be perfect. We're gonna secure it in place with some silicone anyways. Alright, so now, magically, like it was meant to be like this from the factory, the diode bridge fits on the board, and it provides enough room for the capacitors to live in harmony also. I am going to shave some of this glue out so I can bend that out of the way. It's touching the head of the screw, or it's touching part of the screw threads, and I don't like that. So we'll just take the razor. Don't hit the choke. Hitting choke is bad. Cutting glue is good. And this isn't one of those critical glue spots, so it doesn't matter, but If I'm going to bust some of it out, I'll bust most of it out. Alright, and the only reason I did that is because I just want to bend that guy 2 millimeters in the other direction. So that allows the bridge to go back on the board. It clears the resistor, and it'll clear the capacitors now, and the heatsink is happy. And that bridge doesn't get that hot. You know, the surface area doesn't change whether it's vertical or horizontal. Doesn't really matter. I don't believe there's a whole lot of airflow in this section of the amp. So, solder sucker is still hot. We'll solder the bridge in with one leg. Then we'll properly space it and align it. It doesn't hurt to space it off the board a little bit. It ain't gonna hurt nothing. Some of the old Klipsch amplifiers, the dial bridges are spaced all the way to the end of their legs. Sit like 1.5 inches off the board. They work just fine. We are going to get them good and hot so that solder wicks up down in there. Extra step, probably not 100% necessary, but I think it makes for a better repair, so we're doing it. I mean, we're already off in the weeds on this one anyways, so we might as well continue doing a good job for this guy. Alright, everything looks good. Next up, film caps. I think we are finished with the through holes. I pray we are finished with the through holes. I'm going to put that stuff away. And we're doing all this because we want to get that magical 8 volts on the CD plus and CD minus outputs on this amp. That is my equivalent to fan spin. When I get 8 volts, that's fan spin. Some of you will get that reference, some of you won't. If you Google YouTube and fan spin, you might figure it out. And if you really can't figure it out, you can always ask me down the road and I'll tell you what that is. So I see something I don't like over here, more glue. Mental note, we got to get the glue off the back of the dashboard because it did drip down into the bottom and it's going to cause us problems. I'm going to probably have to pull that board out. I really didn't want to do that, but I'm probably going to have to do it. That sucks. The crazy thing is since I got an early start, like, it's really not the end of the world. Typically, I'm just getting started right about now. Oh, maybe a little earlier, probably about 11. That's typically when I would do this. Alright, film caps. Let's clean them. Actually, I think it's time to clean my bench again, too. All this nasty stuff. Try not to cut your fingers off when you're cleaning glue off the film caps. Probably should cut away from your body. these weren't really that bad. I mean, there's some glue on it. It was turning brown, but it wasn't shorting anything. I'm just doing this at this point more so for OCD-ness than function. Let us measure. Set the cap meter. This is just a cheap Amazon special, but it works really good for what I'm doing. That doesn't look good. Let's grab a good one and see what's going on there. So these are 105K. That's a little better. 0.1 UF. These ones should be 104s. They are. So these film caps are no bueno. Let's check the other one. Yeah, this one's a little better. Actually, you know what? Wait a minute. Yeah, that should be 1 microfarad. This one's... So that's definitely a bad one. That's 0.1. This should be 1. I grabbed the wrong one. And I turned my light off. That's a little better. Scared me for a minute. I grabbed the wrong film cap. Yes, this should be 105 is 1 microfarad. That's what we are reading. 1. So we have 1 good one, 1 bad one. Glad I pulled these out, because we would have been in a world of hurt had we not tested them. Definitely bad. By a lot. Into the garbage. Into the garbage. Let's grab another point. Or another... Keep shutting my light off. Alright, 2 good blue ones. So the 104s, these should be 0.1. That one's good. That one is good as well, but we're still going to replace both of them. If we're going to do 2 of the... We're doing 2 of the blue ones, or 2 of the bigger ones, we're going to do 2 of the smaller ones as well. I apologize for the disco lights, but my bench light is motion activated to turn on and off. So you always should check your film caps too. Doesn't hurt. And they're not that expensive to replace, should you have to replace them. Clean up our top pads a little bit. We're just doing that so we can get some solder to flow on them. Probably should have did that before I put the large caps on, but that's okay. Doesn't really take a whole lot to get in there and clean them. I actually remembered to hit the mute button before I blew on it. Get in there with that garbage brush too and give it a little dust off with the garbage brush. But here is the moment of victory. So when you put the film caps back in, they sit nice and straight. Look at that. There's no screw poking into them. They're not bent over. They're just sitting in there like they should. What a novel concept. Wish I had somebody in chat. I'd like to hedge a bet to see if this thing's going to power up first run or not. Soldering one leg. Just to get position set. Make sure they're fully seated in there, and then we can make the solder joints look nice. Probably should have did these first. Alright, all four are tacked in. Now we can do the final seating of them. Gotta pump a little heat into these larger traces. Don't be afraid to leave the iron on there for a little bit. It's not gonna hurt nothing. Just dance it around and make sure you get a good little fillet on there. If you screw one of your other fillets up, or you bridge the joint, just go in there and clean it out. Some people like to drag the iron up. I like to pull it to the side. I think when you drag it up, you end up with really large, like mountain fillets. I like just little, small, tight ones. Does it matter? No. But I think it looks better when you pull it away. Okay, top side of the board is good. What do we have left? We have two seriously burnt gate drive resistors. We have a blown FET that switches the secondary power supply, the main secondary power supply. And I'm guessing probably a couple of blown diodes and some other interesting things down there. Everything else looks pretty good. We still have to do this trace. I'm saving that for last just because the wire's in the other room and it's not prepared right now. I wasn't expecting to have to go through a lot of trace work on this. So we'll get to it, but that's going to be last. So the primary side of the board is good, supposedly. Now we're going to finish up on the secondary side. So these resistors, to get these resistors out, I'm just going to lead clip them if I can get in there. That one just cracked in half, that's cool. So there's no easy or nice way to get these out. Snipping the leads is probably the safest way to do it. And just kind of stand them up and we'll work them out as we can get to them. And those are in bad shape. First time I've ever seen both of those blown. That tells me that some other things are wrong with this amp. Let's see if we can get them out nicely without damaging the board. No more through-hole repairs tonight. So I'm heating up the holes and pushing them as far as I can through the other side. Oh man, it looks like we have trace damage. No. I really hope those traces are not damaged. If the traces are damaged, this is going to become a two-part video. Because that means that all of this stuff here has to come off. Well, let's get in there and clean it. Moment of truth. Hopefully it's just some burnt solder mask. And we might have got lucky. I'd say it was burnt up a little bit. Look at that. Nasty. Let's see if I can get some of this garbage off my mat here. Alright, well, I think we might be okay. I have to check those diodes. I do not know if the diodes are good, but the diodes by the 2-gate drive resistors are always usually suspect. You gotta check them. I'm gonna compare them to my this is my known good bad bench amp. And it's just bad because I had to steal some parts from it. but it's actually good. So we have, okay, diode reads good in that direction. It's in circuit, so if you're measuring it in circuit, it always helps to compare it to another one that's in circuit. Because then you can match the readings, and if the readings are the same, they're probably both good. It's a nice little hack. And we have bad diode. No good? Good. Yeah, this one's reading shorted in either direction. Go on, dog. So we need a diode to come out. That means probably these transistors need to at least get measured. We'll check them in diode mode. I'm really just looking for shorts. That doesn't look good. That's definitely not good. That could be because of the diode, or it could be because of the transistor being bad. I might have to take a break here and let my dog out. Let's see if my dog will say, come here, come here, come here, come on, come here, come up here, come here. Oh, look at this. Look at this. Oh, this is a rare sight. You're going to get to see the puppy. Hey, say hello to YouTube. I know you just want to go outside and get some treats, but this is a rare occasion. That's the best looking dog. Look at the camera, Juno. Isn't that the best looking dog in the frickin' world? It's a good looking dog. I'm gonna go let my dog out. I will be right back. Come on, puppy, let's go outside. Sorry about that. Had to let my dog out. Talk to the wife for a minute. So, okay, we left off with diode being no good. This diode is reading shorted. This transistor is also reading shorted on all three legs. So diode might still be good. Transistor might be bad. So let's take the transistor out. And the only easy way to get this out is just to bend and break it off. All the leads on the bottom of the board are bent. I don't want to deal with them. Alright, so we got them out. I know that's going to be really hard to see, but I'm going to test it. And it's definitely shorted. I can't see any direct signs of failure, but it's shorted, so let's see if our diode is still shorted. Oh yeah. Diode is shorted as well. So, this is a 2N4403. And I don't remember what the diode is. I do remember what the diode is. The diode is a 1N4148. And I cheated. I still have my little slip here from when I had to repair another one of these. But hey, I'll allow it. Alright, let's get that transistor legs out. We'll get the diode out. And again, your average repairing guy is not going to find these. Like, the only way you're going to find this is if you either A, have a schematic, or B, if you've done enough of these to know where the failure points are and you can actually find them. And I'll be honest, I have not done enough of them, but I'm getting good at finding the failure points. Be careful pulling out the legs. And we were already 50% there by breaking them off. You just don't want to damage the through holes. Don't damage through holes. It's bad, very bad. Alright. We can get in here and clean this board up a little bit too. A little better, at least, than we did before. Diode. So I'm going to snip one side. We'll check and see if it's still shorted. Oh, camera switch. Sorry about that. Alright. So our diode well, you can see it. It flashes short. It's shorted. Diode shorted. Diode needs to come out. And that transistor was shorted. And these two FETs need to also be replaced. We'll get to those next. After that, I think it's just bashboard. I'm going to try and get that glue out without pulling the bashboard, but I have a feeling I'm going to have to pull it. Glue is never friendly to me. These legs are a pain. Let's see if I can pull this one out of the back. There we go. Magnetic tweezers to the rescue. Alright, so I'm going to heat up the solder sucker again. We're going to put the small tip back in it this time. See, we're about 3 hours into this already. Not an easy repair at this point anymore. I'm just getting these ready to take out, so I'm just throwing some leaded solder on them just to soften them up a little bit. All I'm doing right now is just clearing these and prepping this part of the board for rework. So while I have this hot, I'm just going to pull out these FETs too, because I know both of these have to go. new gate drive resistors. We replaced a bad diode. We replaced a bad transistor. And now I think the switching section of the power supply should be good to go. The only other thing that could be wrong is the dashboard. I don't see any of the other passive components that look bad or blown. I don't see any soot on the board or burned things. We replaced our caps. We fixed the damage that was there. I think we're in good shape. Let's put our new FETs in. 640s, get 2 brand new ones. I assume they're 640s. I should probably double check. And of course I can't read it because there's nastiness on there. $640s, okay. I thought that's what they were, but I wanted to verify. Give the board a little clean. Just to shine up those through holes. It's not entirely necessary,